Hi, everybody. Thanks for attending today's webinar. This is Tim from Robin Systems, and we're really excited today to have, we think a really interesting topic we think you'll enjoy. The topic is Cloud Native, Big Data, and AIML, Emerging Trends and the Road Ahead. And we're real excited to have as a guest speaker, Noel Yuhanna, who's a principal analyst serving enterprise architecture for Forrester, and our very own Partha Seetala, who's our CTO and also a resident expert and thought leader in this space as well. I'm sure you're all aware, just some quick webinar housekeeping. All attendees will be muted. We will run a couple of polls during the webinar, actually 2. We'd love your input. We'll try to get to a Q&A at the end of the presentation. We'll get to as many questions as possible. So please enter your questions in the question box. And if we run out of time, we'll make sure to get a hold of you with those answers. So let's start it off. I'm going to pass it along to Noel. And Noel, we appreciate you being here today, and take it away.
Great. Thanks a lot. So I guess, we're going to talk about the whole big data and how it's driving some of these new trends and emergence of the whole scenarios of AI as well, because AI and machine learning is a big investment for companies today. And so is big data, actually. So I'm an analyst with Forrester. I cover all of these scenarios today. And I guess, I speak to about 3 to 4 customers every day. These are from the banks, insurance companies, retailers, healthcare, you name it. So I get to speak to understand what they're up to, what are the challenges going on, actually. And I guess I'll share some of those things today in my kind of presentation as well. So let's move on first to talk about big data. Now, as we know it, big data is obviously a challenge itself, right? But data is the new currency and the new oil, actually, right? People are about 7% of enterprises today are making money from data, actually. In fact, you can sell data actually and make money, right? I mean, data is so powerful, actually. And we believe that number of 7% is going to double and triple fairly soon. And this is obviously driving a lot of strategy today. It's fueling this whole innovation and growth for companies, because this is a powerful kind of a data. Data is an asset to every organization, right? And I think the more important is how do we share, collaborate this data across the enterprise. And you have to have some big data initiatives to drive that, which I think is a very fundamentally an important area of focus, right? So the data explosion, I think, is creating this new business opportunities today. About 3.6 actually zettabytes of data today exist, actually. That's huge. Zettabytes, I don't know how many zeros they are, like 21. It may not fit into my iPhone, I think, But this amounts of data is huge. It's from all these sensor devices, video, IoT, social media, their SaaS, clickstream, and what have you. In fact, on my desktop, I have terabytes of data actually already today, actually, right? Because the fact that, we're dealing with all this data, but the problem is that more data is good, but also bad. The more data you have, actually, you don't know how to manage them, right? How do you provision them? How do you integrate them, right? And this is the biggest challenge which most of these companies run into when we speak, right? Now, what's interesting is this actually showcases, what kind of usage we are seeing with the data itself, right? And if you look at an iceberg, right, an iceberg actually only has about 15-20% of the iceberg sitting on top of the water, right, or the ocean, and like 70 to 80% is below the water, actually. Similarly, the data itself is like that in enterprises. Only about 22% of data today is used by businesses for doing insights. Only 22% of data, interestingly, right? What happened to the 78%, actually? It's sitting in those silos. It's sitting in all of those different repositories, right? it's a missed opportunities, right? More data means better insights. Remember that, right? And obviously, you have more insights. You can do better data analysis for doing all kinds of connected data analytics if you're trying to do that, or if you're doing 360-degree view of the customer, IoT, actionable insights, fraud detection, you name it, right? So there's all these opportunities we are seeing. In fact, we're seeing companies that use more data are more likely to have a better insights and succeed in terms of their competitive differentiators, in terms of their innovation, in terms of growth from companies. So definitely, in this era of big data, one should not be afraid about data. I guess more data is good actually, and we have to obviously leverage them. And the good thing is also we have now cloud actually to go to the cloud to actually put all this data there as well, and it's a lot cheaper to do that today than ever before, right? Now, if you look at this 100 years of mega trends in the industry, right? We have come from the age of the manufacturing. We have come down into the age of the distribution with Walmart and Toyota to provide a global connection of transportation systems. And we came into the 90s, the age of the information, which was connecting the PCs and all of the supply chain, what have you, like Amazon, Google's. And today we are in the age of this customer. It's a very important trend because obviously we are talking about this new customer experience. Customer can make or break things today very easily. They can choose one product over the other in seconds through social networks, through friends and families, right? It changes everything, I guess, right? The customer has the power. And that's actually the fundamentally the important thing to understand here, right? How do you build this big data platform to address some of these things? No, our belief is 50%, at least 50% of all big data deployments today on the planet is addressing age of the customer. Customer intelligence, minimizing customer churn is an important area to focus, right? Which is companies what they're trying to present. And customers prefer royal treatment, right? If you look at all of these kind of brands out there, right? I mean, all of these brands actually are catering to customers. They want to personalize that experience. I can give an example of Hilton, right? Hilton has that digital key. You don't have to actually go to the lobby actually to pick up your keys. You go straight to the room, right? That's really customized that experience, right? Which really helps a lot. You can simplify this. You also get alerts from some of these brands, which tells you, by the way, we can give you 10% off for this discount thing which you're trying to buy, right? That's amazing. It's not going to be sent out to everyone. Previously, 10 years ago, we used to send out a circular or invitation to everyone, I guess, right? And that was useless. Here, we're trying to personalize that experience. And this is a big deal because big data addresses those things, right? Next, so I guess before we get into the next discussion in this context, let's do a poll to talk about like what kind of adoption we're seeing with big data as such. So can we roll the poll right now?
Okay, we're teeing it up right now.
Cool. All right. So we got this poll which is, what is your biggest pain point when it comes to big data, database, and AI machine learning? Is it select one, complexity, lack of agility, cost, lack of flexibility, or other? So we're going to pause for about 20 seconds to get your responses back. Okay. Should we get the results and see what the results show up? Can we get the results? All right. So 47% claim complexity is the biggest challenge for them for databases, data, big data, AI, machine learning. Lack of agility, 16%, cost, 16%, lack of flexibility, 0, and other reasons. Complexity, absolutely. I think we agree on that because at Forrester we do a lot of surveys and interviews with customers. And we do see complexity as one of the biggest challenges. It's complex, actually. It's not straightforward, actually, to do. Some of those big data, AI, machine learning, it requires skills, it requires technology, it needs, obviously, product teams to be involved. So definitely, no, complexity is one of those challenges out there. So, okay, let's move on. Can we get the controls? It's, mhm.
Okay, Noel, you'll have it back.
It's not, showing up here. I don't have, it's not showing up as a control. I don't know. You guys know how to see my screen or something? Is it showing up now? I guess it's in the state.
Noel, could you check for a window behind your presentation?
Okay. All right. So, I guess we talked about the big data scenarios, right? So, big data projects are not simple. I guess as we talked about it, right? It's not easy to provision. Imagine trying to provision a 1 petabyte cluster for Hadoop or Spark, right? It's not trivial to do unless you go to the cloud. But then again, cloud also is messy because you can actually have multiple choices out there. What are you going to be selecting? What are you going to be choosing? You can actually have many different scenarios out there, right? So it's a challenge, right? People actually talk about this. Doing it on premise is even worse, actually. Cloud is better and simpler, but still requires a lot of integration, support, agilityness as well, right? In fact, more than 35% of companies have failed on big data. It's not surprising, actually. Why? Because it's complex. We talked about complexity, right? The skills are a big challenge in the industry as well. People don't have the right skills. Cost concerns is again a big thing. We saw 16% people concerned about cost as well, right? And diverse set of technologies adds to the confusion about integration, too many choices with open source. We got 100 of these Apache projects running right now. We got commercial products out there. So adds to confusion as to what technologies to use, what technologies to actually supplement. Obviously, many big data deployments require coding and proprietary lock-in. If you want to move from one cloud to another cloud, you got a problem there as well, right? There's some proprietary lock-ins as well in some of the cloud environments. So, are you future-proofing your environments? Is a very big concern, which companies have there, right? Lack of technical skills is always an issue there, and lack of strong automation. Time to value is important. No one wants to deal with technology issues anymore today. They want to tackle the business issues. They want to come out with the business initiatives, right? Customer churn, IoT, fraud detection, you name it, right? No one's got 6 months trying to figure this out, I guess, right? Everyone wants it like tomorrow, right? So this is definitely a big thing, and this has changed over the last few years as to how do we look into those scenarios, right? It's interesting. So, I mean, And let's look at AIML, which I think is another topic of discussion here. What we see, AIML is actually one of the fastest growing platforms today. In fact, the adoption today, if you see companies, we ask them about these scenarios. What are the firm's plans to the following analytics on AI? People say about 50, 53% of people are implementing or expanding the AI initiatives. But the problem is that 2017 to 2018, the growth hasn't been phenomenal. And there's a reason why, because obviously it's not so trivial to do some of the AI things, right? It's still very early on, it's still maturing, and what have you, right? Which obviously creates a bigger challenge itself. If you look at it, certain regards where you see, we are very so early on in this AI journey. To what extent does your company deliver AI? So this is one of the questions we asked last year across these global companies who are doing AI. And 62% is saying we are just getting started. Even they're doing AI, it doesn't mean they're doing actually anything phenomenal, actually, right? 34% do claim they are delivering something with AI, which is good. I mean, we're still actually on the very early stages here because of lack of maturity of technologies and what have you, right? So the expectations for AI is still anticipated to be positive for the businesses. Now, so people are saying, well, we are still going to be doing AI. Regardless, it's complex. Regardless, may not be benefiting us today, but it will. So like, we asked them, like, how will AI impact your company the most? Well, improve efficiencies and effectiveness. 87% of the companies, it's all about efficiencies. It's all about effectiveness. It's about time to value. It's actually time to innovate and grow. It becomes very critical. Increasing revenue is another very important element which we see companies talk about as well, right? Is another important element which companies mention. Revenue growth is another thing which is critical. So no, so the top intended use cases. So what are people doing with AI in terms of use case scenarios? Well, automating the business processes, right? This is fundamentally an important area of direction. How do you automate those business processes as quickly as possible, yet be able to drive business value from there, right? So we have certainly seen companies doing different types of use cases for AI, right? But the fundamentally important thing is to accelerate those insights, accelerate those actionable insights than what you've done in the past, right? Especially with new data coming in. Like one company was mentioning to me that when the data comes in from the new sources of data coming in, it takes us weeks before we can actually leverage the data for our insights. That shouldn't happen, right? And the problem is that people are talking about real timeness of data, right? No one wants yesterday's data tomorrow, right? They want to be able to act upon these insights right away. So that's a fundamentally a very important factor to consider. Personalized experiences is very, very important, right? How can you personalize that experience, especially as I mentioned, the age of the customer, right? You want to be able to personalize the experience for your product and for your services. Imagine if you walk in the mall and there's always an alert which tells you that, hey, we can give you this discounts, we can give you better services around some of these things. You actually would be really included to include this, some of these things to benefit from these services, right? Right away, as opposed to actually having been disconnected in those experiences. So I think mobile and on big data comes together in some of these, and along with AI, enables some of these new generation of personalized experiences, right? Improving the product and services is number three, based on our conversation with customers as well, right? Now, if you look at but powering the AI solutions, it requires a new infrastructure mindset. So we talked about it that hey, you can actually have all these good stuff actually, but you really need to actually do things like you need to speed up the whole platform. You need to have an agile platform. You need to have a self-service platform, integrated, high performance, scalable, lower cost as well, right? These platforms are doing data preparation, data integration, right? They're doing data transformation. at large volumes at scale, right? You may be preparing data through data scientists. You may be leveraging data engineers to building these platforms. But this platform needs to be agile. It needs to be simplified. It needs to be robust and scalable as well, and self-service enabled, right? So, and that actually is too many things to ask for from a platform. And you can go and build it yourself, which may take a year with many people, which probably is going to be a waste of your time and money. Or you can look for solutions that actually build all these things in a more agile manner, right? Simplify the whole process, which is where I think more people are starting to invest in terms of their scenarios. Now, AI is not about one technology as we know it, right? I mean, basically, it's a combination of things. It's humans involved with knowledge engineering, it's involved with data like machine learning and deep learning. It's also with physics like robotics and sensor perception. So it's a combination of those things to bring with AI, right? So it's not AI, it's just not about like one part of the the equation, but it's many different things involved, from humans to data, along with physics, and it's a combination of those things really makes it a difference with AI projects what we have seen out there, right? So if you look at it in terms of people trying to do different projects out there, one example is the hyper personalized customer experiences with targeted offers. This is what I was mentioning earlier on, right? Uh, the moment you walk in a store, they need to know you that you are there in the store actually. Think about it, right? Those experiences are really real time. They need to know exactly how to upsell, cross sell right away, right? From the millions of customers they have, you're trying to individualize that customer experience, right? Through intelligence. Not that somebody's going to program that intelligence, but to some extent, you actually making this systems more intelligent to know the customer through adaptive intelligence as well, right? Historical data is very important, but also existing sensor data is important, but also log stream, click stream of what people you have been clicking on the websites is important, right? I mean, all those things really create that experience, which I think is fundamentally very important in AI. But also, if you look at it from machines as well, right? I mean, from industrial IoT, where you have these IoT devices and sensors installed to prevent shutdowns. This is obviously for the manufacturing supply chain. Every machine or every unit or a device that goes down can impact their millions of dollars of their product line, right? So these are critical, and predicting them, the failures, is very important. Not after the fact that something failed, actually, right? And those can be done through all the collection of sensors and leveraging the data, looking at historical data, looking at trends, looking at all this information to understand exactly the behavior of those things, right? And those are complex models you got to build, right? The AI machine learning models, when you build on some of these scenarios, take a while to understand, and actually they can be implemented over a period of time. But actually, there's an adaptive learning in these scenarios, which really makes the difference. Now, if you look at it, the whole design of AI, which we have talked about it, is that there's a need for this whole AI infrastructure, right? Because of the fact that you have to have an infrastructure which spans the entire model, right, of life cycle. If you start from that whole top down, right? I mean, if you look at all the identifying the data, integrating and enriching the data, running statistical models, or doing machine learning or deep learning model on these scenarios, testing the model, right? Applying those models, but also making sure you can measure the effectiveness of these models, and pushing the data back into the data to be consumed for analytical and preparation again, right? So, I mean, the whole life cycle requires a dynamic level of integration, right? And this comes back to the point which I was mentioning earlier on, that you really need to have a platform that is more agile, has to have high speed, self-service. It's got to be integrated. It needs to be high performance, scalable as well, right? So that's a very important point here as well. Now, if you look at AI platforms, building them based on we are hearing from customers is not straightforward, right? It's not straightforward to build and deploy. These take time and effort. In fact, Forrester estimates about 25% of enterprises have failed on AI initiatives. In fact, this number is probably higher than 25%. I think 25 is a conservative number, but we'll go with that number. But it's again skills, complexity, lack of vision, with AI is actually failing some of these enterprises. But they're not really turning back. They're saying we'll still wait and see. Maybe we are lacking our expertise or tooling or vision. We'll come back on this initiative again. Again, diverse set of technologies from open source to closed source to cloud services to hybrid cloud to multi-cloud, which creates a bigger problem. AI machine learning platforms requiring coding and skills and technical skills. Can AI machine learning platforms be built by end users today? Well, the answer is not really, right? I mean, we still have some ways to go, but we are getting there. Right. Today, we have to have data engineers, data scientists to help you build some of these platforms through advanced modeling like AI, machine learning, deep learning modeling. But no, those gaps are closing down because with intelligence, AI machine learning can also become intelligent for the platform itself to understand the data, right? And I think that's where the trends are in the future as well. Most organizations are spending time and effort in coding and technical skills, but also on infrastructure setup, right? I think this is one of the biggest concerns which people have brought to us is that they spend a lot of time on infrastructure management, in building these models and identifying business use cases, right? And that's where the most of the time is gone, I guess, right? And some of these could be automated, but they don't look for those automation levels, which I think is important for them to support. So I guess recommendations wise, well, I would say is that focus on solutions that deliver self-service, provisioning, and data management capabilities across data engineers, developers, scientists, and security personnel. Right? You want to have a self-service provisioning and data management capabilities. You want to automate those provisioning capabilities for data management, and the more importantly, across personas. Very important. You don't want to have data engineers working in isolation with developers and scientists having their own tools. You want to actually have common tooling across these personas. Very, very important. And look for those automation points. I think that's a very, very critical point. Number two, modernize your infrastructure with Kubernetes. Now, Kubernetes has been getting a lot of grounds over the last year and a half, and this has become like the standards for companies to deploy, especially to support this multi-cloud, hybrid cloud, agilityness and performance. Right, Kubernetes really drives a better success in your data infrastructure to supporting any of these multi-cloud platforms or even hybrid cloud environments as well, right? So definitely leverage Kubernetes as part of your strategy. Keep security in mind. This is again very important. People forget about security actually when supporting big data initiatives, especially when you're dealing with sensitive data. Now, a lot of big data projects are very well contained. What does it mean contained? Well, there are only very few people accessing big data, like 10 people, 20 people. Why? Because they don't want to open up the whole big data platform to others because it contains sensitive data, especially financial services, healthcare, and some of the retailers as well, right? But if you have secure measures like encryption and auditing, monitoring, vulnerability assessments, masking going on, you can actually still have a lot of people are doing that. You can open up the platform to bigger initiatives, as well. So, I mean, do keep security in mind from start for your AI, machine learning, and big data initiatives. Create a team of experts, which I think is very important to ensure success in big data projects, right? It doesn't mean that you're going to have developers build this platform and that's it. Well, you really have to have a team for AI like enterprise architects, business analysts, data scientists, data engineers, and developers alike working in collaboration to driving use cases, whether it's customer 360, IoT, fraud detection, any of those things, or maybe other in your environments, right? Deploy big data solutions, as I mentioned, which actually really helps you automate those big data initiatives and AI machine learning platforms with self-service and automation capabilities, right? This is very important. The time to value is very important. No one has got a couple of years or months trying to build these. Companies may not even exist in a couple of years, right? Because of the companies and the market trends are changing so rapidly. You really have to act fast and deploy some of these solutions fairly quickly to gain competitive advantage and to support innovation and I guess growth as well, right? With that, I would like to thank you and hand it back to you guys.
Great, we really appreciate it, Noel. We're going to run our second and last polling question. So we'll throw this up there, give it about 30 seconds. Basically, which of below have you currently deployed? If you'd fill it out, we'd really be interested in your input. Okay, great. Looks like the standalone winner would be RDBMS, Oracle, Other at 92%, so that's pretty significant. There are some others, but I'm going to pass this to the person that knows better than I. So I'd like to introduce Robin, CTO, Partha Seetala, and Robin, Partha is going to take it over from here.
All right, thanks, Tim. Thanks, Noel. It's a great presentation on the trends that you are seeing in the database as well as AI, ML, and big data space. Can you guys see my screen? I need to present, right? All right, very good. Okay, so today I'll be talking about, so Noel essentially talked about the trends and his observations from the industry and where the industry is going in terms of both big data as well as AI, ML. And what I want to cover today is, of course, some of our own observations in this space, as well as the solutions that we have thought about and the technology that we have thought about to address some of the challenges that customers are facing. Now, when it comes to big data or even AI, ML, people think about it like, okay, if it's a big data project, then it usually involves something like a Hadoop distribution. Maybe it's Cloudera or Hortonworks. So if it's AI, ML, it is something like TensorFlow. But that's rarely the case, because when you look at an AI, ML pipeline, it's usually made up of several different components. It's pretty much a pipeline with different stages, because you need to get the data from somewhere, which is usually the ingest pipeline. And there are several tools there, things like Kafka, Scoop, and Fluentd, and things like that. Then, of course, you need to store the data somewhere. That could be your standard HDFS, or it could be Cassandra or Kuru or what have you, or even plain vanilla object stores like S3. Once it's stored, you would like to process it. There are several engines to process it. You have Spark, of course, for the real-time analytics. Spark is the clear leader there. You want to do more, relational query kind of things, then you have things like Impala, Presto, those kind of tools. Or if you're doing AI, ML type of processing, then you have things like TensorFlow and Cafe, and there are different solutions like that. Once you process, you have extracted the insights, you put it up somewhere else so that you can serve those results, right? People can go query them, people can go then visualize them. So that's where you have, again, a bunch of other tools. So if you look at it, a typical AI, ML, big data pipeline is made up of several different tools. Now that poses a lot of challenges. And if you look at the challenges and you group them into two different personas that need to deal with this, the dev persona as well as the ops persona, they actually look at the problem statement from slightly different perspectives. For the developers, they essentially want to get started quickly. They would like to get agility of provisioning and things like that. And for them, they feel that, the infrastructure is a big bottleneck. They basically feel that, that is what is gating them. They would really like to get their project started, but the infrastructure is becoming a bottleneck. On the other hand, the ops team, again, this is our observation when we talk to our customers. They basically say that, okay, the developers are interested in trying out new tools, but we then have to go and ensure that those tools are highly available. We need to ensure that they are patched so that they're in compliance or upgraded to the latest versions. We need to ensure that, we are maximizing the ROI on our infrastructure investments and all that, right? So there are two diverse set of challenges for the same set of tools that people would like to go deploy and use, right? Now, this is where, as an industry, if you look at it, there are a few secular trends that are fundamentally trying to address these challenges. They are essentially centered around containerization and Kubernetes. Now, obviously, when I talk about some secular trends, a general AI, ML, big data pipeline, there are several ways to kind of bring the simplicity of deployment, agility, and minimizing the complexity and things like that. Now, there are, of course, challenges around building the right models, and that is where data scientists, the lack of data scientists or lack of training is the challenge. But I'm not going to talk about those challenges. Today, what I'm going to talk about is the first level of challenges around even getting these projects started, right? Which is also highlighted in the survey that we just did, where I think that the numbers overwhelmingly say that complexity and lack of agility are two primary challenges that you folks are facing, right? Now, clearly, Kubernetes and containers are going to revolutionize how that particular challenge is going to be addressed. Now, but why? Why do you want to containerize, right? Now, I'm going to divide it into two perspectives. One is the developers or DevOps perspective. So from their perspective, as I said earlier, right, if you go and ask any developer, the one thing that they hate is open a ticket and then wait for their tooling to be made available by the IT staff. With the cloud, especially, developers have gotten used to a one-click agility where they say, you know what, I'd like to go analyze some data. I know where the data is coming from, and I just throw it somewhere and start writing my MapReduce jobs, Spark jobs, or so on. But they don't want to wait. Now, the other one is experimentation. Now, gone are the days where you would have one team within a large organization that would determine that, okay, these are the only set of tools that developers can use. We are essentially entered a world where developers have access to a lot of tools, and they themselves do not know sometimes which tool to pick. For example, if somebody is trying to build some analytic pipeline today where they'd like to run some queries, now they have a choice between choosing RDBMS or document databases or graph databases. And clearly they cannot really come out and say, okay, this is where I'm going to start, because there are different reasons why they might want to pick one over the other, but they have to first experiment and then figure out if that particular technology is well suited for the problem that they are trying to solve. So experimentation and iteration is a very key ingredient when developers look at AI, ML, and big data platforms. The next one is developers hate to basically be locked down into a particular infrastructure choice. Ideally, they would like to liberate their entire tooling and their applications from the underlying infrastructure. They might want to run it on a laptop, or they might want to run it in their own data center, or perhaps even the public cloud. So a couple of reasons to choose one over the other, right? One is, of course, where the data is originating from. Two, where they have the capacity to go and store and run these analysis and the queries and things like that. And three, whether there's any specialized hardware that they would want. For example, if they want specialized GPUs or TPUs, then they would prefer maybe one hyperscaler over the other. So those are the kind of choices that developers would like to have. Now, this is where I think containerization essentially solves the developers' challenges, right? Because it provides it offers a deployment agility and infrastructure independence that developers are looking for. Now, let's look at it from the other perspective, which is the infrastructure perspective. Now, we have done a lot of surveys ourselves, and we have talked to a lot of enterprise customers. And they basically say that the utilization of their big data clusters is pretty low, right? Now, again, there are several contributing factors to that. So let's look at that. So number one is, with every hardware refresh, you're ending up with a lot more resources or a lot more compute, memory, and storage capacity than the last time when you purchased your machine. So this is actually a real stat. So for about, let's say, 25K, 4 years ago, you would get machines which had about 40 cores and 128 gigs memory and so on. Today, for the same price, you get about 40 cores and 512 gigs memory and 144 terabits and terabytes and so on. So essentially, your capacity for the same cost point, that's basically exploding, doubling or more than doubling. On the other hand, you also have this thing where you're getting machines that have a lot of capacity in them, right? So again, I just did a quick analysis on this. About for 34K, you can actually get about 540 terabytes and 256 gigs of memory and 24 cores in one box. Something that was unthinkable about 4 or 5 years ago. It's possible today. Now, on the other hand, if you have things like NVIDIA's DGX boxes, which have a lot of GPU cores and all that, and it costs a lot of money, right? Now, these machines are clearly going to be underutilized because, A, you cannot really have just one process or one tool drive this much amount of capacity. Now, this is where, again, containers allow you to go and do consolidation and as a result, you'll be able to maximize your infrastructure utilization. So there's a two perspective, right? The developer's perspective, they look at it more from an agility perspective, and the ops as well as IT, they look at it more from a utilization perspective. Now, here comes Kubernetes. You already mentioned that Kubernetes is taking the world by storm. So this is a report that I ran just last night, just to kind of see what has been the growth of Kubernetes. And if you just look at this graph, right, it's amazing that in such a short time, we have this technology that has just taken over, right? And it is pretty much just as much as people are talking about AI, ML today. I think Kubernetes also has the same level of attention that it's getting from developers, right? Developers as well as IT staff and so on, and big data providers. Now, while Kubernetes is great, it's a very, very complex platform, right? Everybody talks about Kubernetes is going to revolutionize, but seldom do they really say that, you got to do a lot more on top of Kubernetes if you really want to solve some of the agility as well as complexity challenges. So this picture kind of illustrates what people typically face when they're trying to onboard their workloads on top of Kubernetes. So think about it like you have all these great parts that Kubernetes offers, right? And you're trying to, let's say, build this entire tooling or a platform, or in this case, a lot of great parts to build a car. And you put all of these things together, and you expect that you're going to see a great, nice, agile car like Tesla. But what you end up seeing is something that looks like this, right? Because all these parts, when you put them together, they really never come together as nicely as you would essentially plan for or anticipate. Because if you look at it, you have to essentially stitch things across different domains. One is container management, storage management, network management, and of course, at the end of the day, big data and application management and things like that, right? Now, this is where we think that a new way of looking at the problem would help bridge this gap of having a tool like Kubernetes and then bringing it to the masses where they can go and onboard their big data and database and AIML workloads. Maybe I'll skip this part just in the interest of time, but just to kind of highlight three key areas that one needs to look out for when they are trying to onboard big data and databases on Kubernetes is the fact that most of the big data and database tools that you're using today predate both Docker and Kubernetes. They're not built as microservices. So you really need to do something to ensure that they run smoothly on a platform that is designed for microservices. Then it's around the storage area. If you're trying to consolidate your big data platforms, think about it this way. Let's say you are running multiple Hadoop instances on the same server. You are essentially consolidating. But if you consolidate those without guaranteeing performance predictability, then your developers are not going to like it because they are essentially going to see very unpredictable query performance when they're running their analysis, right? On the networking side, Kubernetes, while it is a great platform, it is very complicated to network everything together and expose it as a service to the end users. So developers typically struggle a lot to essentially run their tools on Kubernetes, but also provide network connectivity to those tools once they're on it, right? So that's where we have thought about this problem from a very different perspective than some of our industry peers. Because what we have said is, what the world needs today is a very simple platform that is built on top of Kubernetes, right? While it hides all the complexity, it provides all the reinforcement that Kubernetes needs so that you'll be able to run these platforms in a very agile and a simple manner. So we start in our platform with Kubernetes, stock Kubernetes, or any other distribution of Kubernetes. We bring to that a custom scale-out file storage subsystem that we have built. And this storage subsystem is application aware, which means that your developers do not have to go and tinker with the underlying storage volumes or doing LUN management and things like that. And instead, they would just be able to go and describe, okay, this is the kind of needs I have from a storage capacity perspective and a storage performance perspective. And this layer is going to then talk to Kubernetes to provide those guarantees to the needs that the developers have expressed. On the other hand, networking, as I said, is a challenge. We bring in stock Kubernetes CNI plugins, but on top of that, we also make networking a lot easier by providing certain primitives that provide client to the workload connectivity, which makes it a lot easier, as well as pod-to-pod connectivity a lot easier. But these three are still infrastructure level components. And at the beginning, we basically said, and also the survey kind of indicates that complexity is the biggest impediment for a success in a big data project, right? Or agility is a lack of agility is also a big impediment, right? So if you just leave it at the infrastructure components such as storage, Kubernetes, and networking, you're not really addressed those two concerns. This is where we have built our fourth component in the tooling, which we call as an app workflow manager. And this truly revolutionizes how you simplify these platforms when they run in a Kubernetes environment. So this layer essentially exposes a set of primitives that enable the developers to go and just describe the structure of their app, describe the resources that they need for their app, and this layer will then take those needs and then translate them into the underlying infrastructure level calls. So the developers then don't have to worry about the infrastructure at all. So think about it like we make infrastructure invisible so that developers can focus on their application and on their workloads. And we do that regardless of where you're running this. Because the other thing that we said is developers want infrastructure independence. They want to liberate their apps from private clouds or public clouds and all that. They just want to run it wherever they see the data is coming in or wherever they see they have the capacity to run these workloads, right? Now, maybe a small demo to kind of illustrate what would it look like when you simplify this. So this is a dashboard of the Robin platform. And in this dashboard, you can see that there are a bunch of workloads that are already uploaded and ready to go. And Noel also mentioned that in his recommendation that what customers are looking for is a self-service platform, right? Now the public cloud environment has done a great job of having people hooked to that, right? Where you can go sign in with your account and then just go to a dashboard and say, click, and I have my, let's say, database up and running. So how about you take that and provide it for a wide variety of applications, not just in one specific public cloud, but also on your data center or any other cloud. So that's what this platform does. And as you can see, you have all a catalog of a lot of applications, and you can onboard any other application in a matter of a day or so on this platform. So let's say that since we're talking about big data, let's focus on one thing, right? The Hortonworks. Now, Hortonworks, as you know, is a very, very complicated platform. It's not just HDFS. It's not just Hadoop. There's so many different tools, components and services that need to be enabled and interconnected and so on. So let's look at how this simplifies that. So the developer goes, clicks on Hortonworks, and then we render a screen that looks like this. And in this screen, the developer or the big data architect can go and just toggle and pick the services that are of interest to them. Like, for example, they would say, I want Hortonworks with Hive, Kafka, and Atlas, right? And Spark. Just toggle and pick that up. And once that is done, they can just go for each of those services. They can specify the scale at which they would like to deploy that service. They can specify the capacity compute capacity that they would like to allocate to it, and the storage capacity that they'd like to allocate to the service. Nowhere do they have to say where it is coming from. They don't have to say where the compute is coming from, where the storage is coming from. They just say this is the scale and these are the resource requirements. Beyond that, they would also be able to go and specify certain constraints, because unlike a simple stateless workload, something like a big data workload like Hortonworks has a set of rules that need to be followed very strictly if you really want to make this run in production, so that it's highly available and performant. So Robin also allows you to go and toggle these switches and say things like, okay, I'd like to anti-affinitize certain services, because if you put them together, then you would essentially increase your probability of failure, right? So you can say, I would like to keep my data nodes away from Kafka and name nodes. Or you would say, you know what, these are very high throughput intensive workloads, so I'd like to get data locality, so I minimize my network traffic. So you can go and toggle and say, enforce that storage and compute are locally co-located, right? So with that, you would be able to go and save this entire, you compose your app, you can save it as a template. You could say Hortonworks with Hive and Kafka, small, medium, large. And once you have that, you essentially have enabled a self-click experience for your developers. They can go and click on it, and then what Robin's app workflow manager layer does is it takes these things and translates it into the appropriate storage, Kubernetes, and networking calls, so the developer doesn't have to do any of these things. And it also hides the underlying differences between running this in AWS or Google Cloud, Azure, on-premises, whether it's running on bare metal or in a VMware environment and things like that, right? Now, that's one thing. I also talked about from an IT and ops perspective, it's very important that they provide the facilities so that you can scale the capacity of your big data cluster once it's deployed. and also eliminate noisy neighbors, because this platform allows you to consolidate. So how do you do that? So you do that by pretty much allowing a QoS or a SLA that you can set for your workloads and say that, okay, this workload is a very important workload, so I would like to go and guarantee a certain number of storage IOPS, CPUs, and memory, and so on. Or you could say, you know what, this is not such an important one, so I'd basically like to throttle it down to a certain number, right? And we all know that, the priorities of your organization, of your application, all that changes. For example, end of quarter, you'd like to close your books, you'd like to run a report, right? Now, for that workload, pretty much the last 2 or 3 weeks of the end of the quarter are more important. So you should be able to go and dial up the resources that you allocate to that application. And that you can do by trading it from the adjacent workloads that are running on the machine. So you really need a platform like that, and Robin allows you to do that very easily by just toggling a switch and saying, you know what, this is the kind of capacity I'd like to allocate, and then take it away when it's not needed. Now, this is all great, but once you have it up and running, you also would like to go and create checkpoints of your workload so that you can go back to a clean state if things go bad. Now, the industry has been used to things like snapshotting and backups and things like that. But typically that is done at a storage level where you're trying to snapshot your storage volumes, you're trying to snapshot your or back up your storage volumes and things like that. So what we have done is, again, if you want to put this power into the hands of the developers do not want to deal with how to snapshot the storage array or how to back it up and things like that. What they say is, okay, I have an operational database that I have spun up. Let's say it's Cassandra, as you can see in this picture. They would like to go and say, I would like to snapshot my entire Cassandra application, along with its data, along with its app topology, along with any policies that were set up when you're deploying this workload. Because once you do that, I can just go back and I can do a time travel across different states that I've preserved. So Robin allows you to do that by a tooling which is essentially at an app level, you can trigger snapshotting or creating checkpoints. So you go to the top here, click on actions, give it a name or snapshot, and then just click create. What Robin does is it creates an app consistent snapshot across all the volumes that are running across all the pods of this Cassandra application in a matter of seconds, right? Now with this, you can truly enable a Mac style time travel for your entire apps along with their data, right? Now once you have this, you can also provide the power to the developers to go and look at the catalog of snapshots and say, you know what, you can go very quickly create a test dev clone so that you can share your app along with the data with another developer, or you can enable sharing from test to dev or production to staging or production to dev and things like that, right? So it pretty much makes it very easy to go and share your workloads along with the data very easily, right? Now, with that, I come to the end of my presentation. I hand it back to Tim.
Awesome. Thanks, Partha. That was great. We're coming at the top of the hour, so we have a number of questions here. We'll get to a few, and again, the ones we don't get to, we'll answer directly to you. So I think this one I'll tee up for Noel. Noel, someone asked, how should we proceed with big data initiatives that are complex and large?
Yeah, no, that's a good point, actually. The fact that when you have large and complex big data or even AI machine learning scenarios, like how do you deal with it? First of all, I think to the point here is that you want to automate, simplify that whole process on the stack, right? Because if you don't do that, the complexity is going to really push down these projects, actually, first of all, to elongate the whole process, but also incur additional cost, actually. So first of all, you have to look at the automation as the key enabler for driving some of these big projects. You got to sit down and see exactly what all automation do you need, whether it's going through Kubernetes, whether it's through solutions, where they're automating the whole stack from ingestion, processing, transformation. All those things have to be considered for large projects, especially when dealing with petabytes of information, right? You can be people I know build up and spin up Hadoop clusters for petabytes, and then realizing after 2-3 weeks later that, well, this wasn't actually useful because that cluster is doing nothing actually from day one actually, and they spend all this money on those petabytes of data doing nothing. So this planning required, as I mentioned. You could have a team. You could actually have some initiatives in plan. but also look at the solutions that can actually automate the whole stack processing from ingestion, processing to integration, to actually provide you that better insights and the value you need, right? If you don't do the automation, then guess what? Well, you're going to incur more cost and people time and resources, and may not really be valuable, So.
Great. This is actually a public cloud question. Someone asked, how do we leverage the public cloud more broadly for our AIML and big data initiatives? For Noel.
For me, sure, I can take that. Public cloud is obviously, you actually have a lot of these public cloud providers from AWS to Google to Azure and others. And, they actually are helpful in terms of accelerating that, right? The fact that you actually have these services installed and configured. But the problem, I guess, is that, not all data sits in one single cluster. People are building multiple lakes now. And if you have multiple lakes and clusters, it becomes difficult to manage and support as well, right? Most of these services cloud providers actually just focus at that layer of building a service platform, but they don't really go to the whole stack at the end-to-end stack. Whether it's from application perspective, insights perspective, the whole stack needs to be integrated as well as automated, right? So there are some work to be done through third-party vendor solutions, which I think would be helpful, for those companies.
Fantastic. We have about a minute left, and we're going to slip one more in here. It's, of course, about security. And someone asked how to secure big data and AIML platforms when dealing with sensitive data.
Yeah, another important question, is security, right? As we talked about it. People tend to forget about security, actually. When you're going, hey, I'll just put big data and AIML platforms and just leverage it. Well, not really. You'll be surprised that sometimes when you dig deeper into these data, there's sensitive data actually sitting out there. There'll be some customer data, could be some business data, which could be sensitive as well. Not necessarily customer data, but also business data. So you don't want to keep it openly available. You obviously want to encrypt it or mask the data as much as possible. And you have to have control teams. Like I was speaking to one of the banks. Banks obviously are using Hadoops and lakes and all, and they control those platforms as such that only few people can access those who have got clearance to access that. But yet they also go through transformation, through masking, through some of the encryption to make sure that that's all protected. Because obviously, there shouldn't be anyone actually breaking in actually and using the data as well, right? So there are some controls which needs to be in place. Very important is that as soon as your initiative starts to take off, you need to have security nailed down right from day one, and I have a team of players actually to work on security policies and governance, which is again a very important topic on big data and AI, which needs to be enabled as well, right? But I wouldn't expect people to open up the whole big data platforms and AI platforms for everyone in the organization. You start with a very controlled few people, and especially when you're dealing with sensitive data.
Awesome. So listen, I promised that we'd wrap this thing up.
There's one more question.
There's one more question. Okay, Partha, you grab that?
Yeah, there's a question that I see on the chat screen. The question is, does this mean Robin can help deliver Elastic as a service? Do you have any customers in production? Absolutely. Elastic is one of our great platforms that works very well on Robin. In fact, we have the fifth largest financial services company in the country that runs their entire security analytics pipeline on an ELK plus Kafka stack. And they ingest about 11 billion security events into the stack running on Robin every single day. Now, a couple of things here, right? So Elastic is, the reason why it's a great platform is, of course, people need agility. But Elastic is one of those things where people keep on dumping data into it because they like to preserve this data for a long time so they can run queries in the past as well, which means that you have to have a very agile, scalable platform where you can add capacity as the capacity needs increase. And that's essentially what Robin provides very easily, right? So the IT staff who are managing it or the developers can just go and say, okay, I'm running low on juice, I can go add more capacity to Elastic. I'm running low on capacity, I can add more storage to it and so on. So yes, Elastic, we have production deployments, very large scale Elastic deployments on Robin.
Great, I'm glad we got that in. So as we're winding down here, I first want to thank both Noel and Partha for the presentation. Great job. And also want to thank everyone who actually attended the webinar. As we mentioned, we're going to package this up, the recording, and we'll shoot it out. You can watch it at your own pace or pass it along. And then also, if there are any questions about this, and we at Robin, we think that nothing beats a live demo of Robin in action. So if you're interested, shoot me an email, tim@robin.io, and I'll get you in touch with someone that we can do a technical demo for you and see actually the Robin product working in, live in action. So that's going to do it. Again, thanks everyone for attending, and we'll be in touch.